you have this slide deck in the participants material. I will anyway leave it open here. So this is what you have to do, what you are proposed to do as the first exercise. Use the Parallelware Trainer to open the Pi project. And you get familiar with all of the options of generation of code, understanding the patterns, the different features of the graphical user interface. Here you have all these steps that you need to do to run Parallelware Trainer on CORI. So you are supposed to have an account to connect to CORI. All of you have accounts, okay? So you can SSH with X11 redirection because this is a graphical user interface. These are the examples that contain the Pi, LULESH MK, and HIT practicals that we propose to you. So copy them from this global directory into your home directory. Then you need to load some modules to use Parallelware Trainer. So you have here all the sequence of modules that you need to load in CORI to have the appropriate OpenACC and OpenMP for GPU offloading support in these compilers. Okay? Just copy and paste, making copy and paste of these commands should work in your terminals. Next, you need to allocate an interactive session in one GPU node of CORI. So you can do that with this. If some of you have some issues with this, Helen can help you.
Why there's a dash reservation. And also, if you do not belong to M1759 before, we added you to the stream so you can have access to the GPU node.
Okay, you can see it here. There is a note here. Some of you might need to use -a in staff or -a dash repo, something like this. Okay, so once you allocate this interactive session, you have essentially a terminal where you can run commands. Just invoke PW trainer with an ampersand, and the graphical user interface will appear on your screens. And at that point, you can start. You will need to activate the software. The first time you run it on your account, you will be presented with a dialog that you need to open this file to activate the software and have access to the capabilities. Okay? So it is shared in this path that should be accessible to all of you.
That's also on this worksheet.
Yeah. You all have copies of the worksheet. So in the beginning, you have a section with all of these steps. You also have, just if you don't remember, you have these dialogues. And here you have the commands that you need to use using GCC, PGI, OpenMP, OpenACC, for instance, to compile the Pi example. Okay? So you can just copy and paste them in the appropriate dialog of the UI to build the binary code, the executable code, and to run the code either on the CPU, either on the device using the GPU. Okay? You have here the commands you need to use. And finally, we have been talking about the composition in patterns. So what is Pi? Pi is very simple. It's just one simple single loop with one single variable that is a scalar reduction pattern. So you can apply all these strategies that you have in the worksheet. One more final thing regarding the practical of LULESH. The recommendation in the worksheet, we have been discussing that yesterday between the trainers, is that you first get familiar with all of these patterns, strategies, implementations, the UI through the Pi example because it's one loop, very simple to understand. You already have the notion of a scalar reduction before going to the complexity of LULESH microkernel. The second exercise that we propose is using LULESH MK. So essentially, this is hydrodynamic code. You really don't need to know anything about the science, as I remarked before. You just need to focus on the code and understanding the properties of the code. This is what you are really parallelizing. And indirectly, you are, of course, parallelizing the science. So again, you have, in that practical, the trainer UI, all the options, again, to run the trainer, all the commands to build and run LULESH MK. And finally, you are provided with 3 additional slides. We said that in the general workflow, this is probably the first time you see this code. So where do you begin? You will be presented with 20 routines, 12 loops. Where could you begin? You can go one after another sequentially, or you can do something more intelligent. So to do something more intelligent, follow with the general workflow is begin profiling the application. So just running these commands, enable -pg, you will be able to run the code, and with gprof, you will get this kind of output. And this will be probably your first profiling of an application, that you can later reuse these commands to try to profile your own code, your own applications. So here what you have is a rank of the routines of the code and the time invested in the execution in each of the routines. So you can clearly identify which are the routines that consume most of the execution time and begin to focus, begin working on those routines. Okay? So first experience with profiling for some of you. Okay, when you run it and when you run the sequential version and you run the parallel version, how do you know that the code has been parallelized correctly? You need to verify the output somehow. Pi is very simple. Just look at the 3 point something, and in just a glance you can say, okay, this is correct. But LULESH is much more complicated. So we have extended a bit the output of the LULESH MK, of LULESH example, and here we highlight in boldface what you need to focus on to verify that the code is correct. So when you generate a parallel version, run it, have as a reference the sequential execution, see the elapsed time if it has been reduced, and also check that these values are more or less in the same order. Because if there is a very significant difference, then there is something that has not been parallelized correctly. So it's important that when you generate a parallel code, before iterating in parallelizing another loop, that you always run and verify that numerically it is correct. It doesn't matter if it accelerates, runs 2x faster, but it provides you incorrect results. Has not been correctly parallelized. Okay? So don't focus only on the time, but also on the numerical verification. And finally, just to give you a glance of the complexity, this is the table you need to fill in. So in the LULESH MK, in Pi you have only one row with only one example. Here you have 8 or 9 routines with 12 loops. And here you have the solutions to some of the cells. So in loop at 973, you will find a loop that contains a pattern parallel for all that computes and saves the result in a variable of this name. So you need to go to this loop and see if this is the only variable that is computed in that loop, or if there are more variables. If there are more variables, you need to write the name of the variable in the corresponding cell corresponding to the pattern. Okay? So somehow we are giving you an example of a loop with a parallel for all, a loop with a parallel scalar reduction, a loop with a parallel sparse reduction. Boldface, this is the main hotspot of the code, where you have sparse reductions. And forget about this convergence loop. This should have been deleted from this table. Okay? So somehow you need to fill it in with the names of the variables in the appropriate cells of these columns. And we have the results. So at the end of the practical, we will, before closing the session, we will share some time discussing the results for Pi on CORI and for LULESH MK on CORI, so that we can all share the experiences and results and learn from what we have all done during this session. Okay? Okay, so let's stop here, working lunch, and begin to work on this, and just let us know how we can help you during these practicals. For those of you that have your own codes, maybe we can first suggest to make some of the practicals, and once you get used to the concepts of patterns and things like this, we can try to apply it to your own codes. But it's up to you. Also, if you want to start by your code, we can sit with you to see how it is organized. But I think it's better to invest at least 1 hour trying to understand all the outcomes of these lectures. Okay, but please understand me well. It's up to you to decide how you want to do it. These are free hands-on sessions. You decide what you want to invest your time in. Okay.